Buongiorno baddies, welcome back to another video. Today's first question is, Terry has sticks of length 9 inches, 12 inches, and 14 inches. She cuts the same amount off of each stick. After cutting this amount off each stick, she is no longer able to make a triangle by attaching the sticks end to end. Shocker. What is the smallest amount Terry could have cut off each stick? Okay, who takes sticks in the wild, measures their length, and then tries to form a triangle with them? Also, how is she cutting the sticks, perfectly, a couple inches off? Is she superhuman? Okay. So, anyway, not the point. Since the only way that Terry could not make a triangle anymore is if the lengths of the two shorter sticks added up is no longer greater than the length of the longer stick added up. And this is basically according to the formula, as I've said in a lot of previous videos, if A, B, and C. So that means that A plus B has to be greater than C plus B has to be greater than A plus C has to be greater than B, and so on and so on. Therefore, following that sort of formula, this means that since it's the two shorter sticks added up is at the point where it's not greater than the longer stick anymore, that is when the ability to make a triangle has been diminished. So basically, assuming that the amount that she cuts off each stick is x, this means that 9 minus x plus 12 minus x is equivalent to it has to be less than or equivalent to, because it has to be in a regular circumstance where you could actually make a triangle, it has to be greater than. Therefore, in a circumstance where you cannot make a triangle, it has to be less than or equivalent to 14 minus x. And if we move this x to the other side, so plus x, so these two x's are gone, and then plus another x, and then move the 14 to the other side, we'll get 7 has to be less than or equivalent to x. And this means that the smallest amount Terry could have cut off each stick is equivalent to 7. Big fancy 7. Moving on to problem number 2. Suppose we have AB is equivalent to 8, BC is equivalent to 10, CD 16, and DA 12 in quadrilateral ABCD. How many different possible integer values are there for AC? So the problem above and this problem are sort of on par in the same topic technique sort of thing. So this time, however, as we've split down the center of this quadrilateral already, you see that there are two rather distinct triangles, quite a few problems that I've done. How interesting. So I'm going to highlight these two triangles real quick, and this means that we have to take an appeasement, sort of, from both of these triangles, and it has to fit both of the triangles because the line is splitting the two, and it is also a side for both triangles. And using the formula above, we can find out that if 8 plus 10 has to be greater than, let's say that this line is x, has to be greater than x. That was legitimately not even in the equation anymore. 10 plus x has to be greater than 8, and 8 plus x has to be greater than 10. And unless x is a negative number, which is not possible since this is a 2D polygon geometry question, this means that 10 plus x is greater than 8 is not a necessary equation. Therefore, 18 has to be greater than x, and x has to be greater than 2. And in the same way, this means that for the triangle below that triangle, aka ADC, triangle ADC, using those as A, B, and C, we have 12 plus 16 has to be greater than x, 12 plus x is greater than 16, and 16 plus x has to be greater than 12. And just like the first set of equations, the 16 plus x, unless x is a negative number, this is always true. Therefore, this bottom equation is not necessary. So this top equation basically says that x has to be less than 28. So 28. Oh, that's not an x. And 12 plus x is greater than 16. Therefore, x just has to be greater than 4. And now that we have our sets of equations, we just need to find a sort of center for both of them. Because the top one, it says that x has to be less than 18 but greater than 2, and the bottom one says it has to be less than 28, and greater than 4. X can be less than 18 while also being less than 28. Therefore, we're going to take x is less than 18 for the less than value. Similarly, x can be greater than 4 while also being greater than 2. Therefore, we're going to take x is greater than 4 as our greater than value. And if we put that into a formula, this means that, I'm going to zoom in back here, x has to be less than 18 and greater than 4, which is now our final solution. Which also means that how many different possible integer values, since it cannot be 4 or 18, this is basically 5 to 17. And to calculate how many there are, that means that it's 17 minus 5 plus 1, so 12 plus 1. Therefore, there are 13 values in between this. So yeah, that's the end of this video. I hope you guys enjoyed, and I hope you guys learned something new, and I will see you all on the next one. Bye-bye!